Welcome to my presentation on statistical analysis. My name is Laiba Babar and I will take you through an insightful analysis of sales focusing on distribution and variability. In this project, we explore sale data to uncover trends and variations. The key focus areas are statistical measures, including central tendency and dispersion, along with data visualization techniques to better understand the results. Here's a snippet of my data set. If you want to see the complete data, for that I have provided the link in the end. You can check that out. Why this data set? The data set was chosen for its real-world functionality in analyzing product sales trends. It contained information about products, quantities sold, prices, and customer locations, which are critical for understanding business performance. Importance: this dataset enables insight into seasonal patterns, best-selling products, and regional preferences, which are key for businesses to optimize inventory, improve sale, and target marketing efforts. Relevance: by analyzing this dataset, we can make data-driven recommendations for future businesses and improve decision-making. Here's an overview of the dataset. In total, it contains 30,246 records. The key columns in the dataset are order ID, that is a unique identifier for each order, product, that is the name of the product sold, quantity ordered, number of units of each product sold, price each, price per unit of product, order date, date and time when the order was placed, purchase address, customer's address used to deliver the city of the purchase. Data cleaning process. Before analyzing the data, I performed some data cleaning to ensure that it was ready for analysis. Data cleaning in any data analyzing process is a crucial step. We handled missing values like converted columns like quantity and unit price to numeric types and created a total sales column. These steps ensured the dataset was ready for analysis and visualizing. Libraries used in dataset are Pandas for data manipulation and cleaning, NumPy for numerical operations, Matplotlib and Seaborn for data visualizing and analysis. And the programming language that I've used in this project is Python. Now here are some key visualizing diagrams. Monthly sales trend. This bar chart displays the total sales per month. From the chart, we can observe patterns of high and low sales period. For example, the sales peak during certain months, which could correspond to holiday seasons or special promotions. This helps in sales, which are critical for businesses to plan marketing campaigns and stock inventory accordingly. Top 10 products by quantity sold. This visualization shows the top 10 best-selling products based on the quantity ordered. We can see which products are most popular among customers. These insights are valuable for businesses to prioritize the production or stocking of these products to maximize revenue. Sales distribution by city. This bar chart represents the total revenue generated by each city. It highlights the top performing locations where the highest sales occur. Businesses can use this information to focus their marketing efforts in high performing cities and understand regional preferences better. Now I will explain the Python code used to analyze our sales dataset. This code covers various statistical measures, data cleaning, visualization, and advanced matrices like skewness and kurtosis. The library used in this code are Pandas, that is for data manipulation, NumPy for numerical calculation, Matplotlib and Seaborn for data visualization, Skippy for statistical functions like kurtosis. I started by importing the necessary libraries. As you can see, that is Pandas as PD, NumPy as NP, Matplotlib, Seaborn and Skippy stats. Next, I loaded the dataset using Pandas. Here the CVS file is loaded into a Panda data frame for easy processing. To ensure that our data is clean, I converted the quantity ordered and price each columns into numeric format. I then created a new column that is total sales by multiplying quantity ordered with price each. This column calculates the total revenue generated per order. I displayed the first few rows and summary statics of the dataset to check its structure and basic statics. To analyze the distribution of total sales, I divided the data into 10 bins, data intervals. This splits the data into 10 equal size intervals and calculate the frequency of data points within the class. I also calculated class boundary, that is the start and end of endpoints of each class. Also class width, that is the difference between the upper and lower boundary. Class mark, that is the midpoint of the class boundaries. I then plotted the histogram of total sales to visualize the distribution and a frequency polygon and a cumulative frequency polygon to show the cumulative total frequency. I then calculated the following measures of central tendency, that is median, the middle value in the sorted data, mod, the most frequent value, arithmetic mean, that is the average value, geometric mean, and harmonic mean. These measures provide insight into the center of the data. I then calculated quartiles, decile, and percentiles to measure the data spread. These matrices help understand the distribution and spread of the data. I also calculated standard deviation, that is the spread of the data, skewness, that is the skewness I've calculated after this, yes. Skewness, that is basically you can define as the asymmetry of the data. Kurtosis, that is to measure whether the data is heavy tailed or light tailed. And based on the skewness and kurtosis, we can define whether it is positively or negatively skewed. If skewness is greater than 0, then the data is positively skewed. If it is less than 0, the data is negatively skewed. And over here, I've also calculated the coefficient. As you can see, I've calculated different coefficients like coefficient of range, variation, mean deviation, and standard deviations. Then I've also calculated standard deviation by Carl-Pearson method and Bolles method, and I've calculated Bolles skewness. Then moments, about the moments I've calculated about the mean and about arbitrary origin and some other origin. Now I'm going to show the output of this project. After running this cell, I will get this output, that is first displaying all the data frames, then class boundaries, width, mark, class limits, that is the frequency and the total sales. Then it has shown the cumulative frequency, total sales. Then a table is displayed that is containing all the class limits, frequency, and cumulative frequencies. Then the graph of histogram, that is of the total sales. Then you can see the frequency polygon graph and cumulative frequency polygon graph. And then also the central tendencies that I've calculated, mean, modian, skewness, arithmetic, quartile, deciles, and all that. Then the coefficient of range and variations and standard deviations. Then I've calculated Carl-Pearson method, that is a NaN values, that is not a number value. Then you can see I've calculated first moments about mean, arbitrary origins, and kurtosis and all that. And the data, after calculating, I get to know that the data is positively skewed. So now you can see here's the reference slide, that is I've taken the dataset source from the Kaggle, that was the e-commerce sale analysis, and also the tools that I've used in it is Python, Pandas, and Matplotlib and Seaborn. So in conclusion, this basically the project, it demonstrates how statistical analysis and visualizations can uncover important trends and insight from sales data. By identifying these patterns in sale, production, and regional performances, the business can make a decision to optimize their production and value. So, thank you for watching. I hope you find this analysis insightful, and that's all for my presentation. Thank you.